Hello friends, welcome back. Today we'll start with the eighth video lecture of chapter 9 ray optics and optical instrument. In our last video we have studied about total internal reflection. If you like my videos then please subscribe this channel. Okay, now let's move forward today with the uses of total internal reflection. As I said in last video we have studied about total internal reflection. Now we'll study about uses of total internal reflection. Okay, so the first use is you can say glittering of diamond. Okay, the diamond refractive index of diamond is 2.42, right? For diamond, the refractive index is 2.42. Clear? So if I found out the critical angle, sine C will be equal to 1 by n. Means so it's 1 upon 2.42. So we will get the critical angle C will be equal to 24.41 near to this. Approximately the critical angle will be 24.41 degree. Now this critical angle is very less. So whenever the ray of light incident on the surface, inner surface of the diamond, then the angle will be always greater than critical angle. So the ray of light will be totally reflected internally. Just take example, if I take this as a diamond, okay, what will happen whenever a ray of light it is entering in this way? This will be the normal angle of incident, will bend towards right. So now this is the normal. Now this angle will be less or greater than critical angle. In most of the cases, this angle will be greater than critical angle because critical angle is very less, 24.41. So what will happen? This ray will not be refracted. Instead, it will be reflected. Again, this will be greater than critical angle, reflected. Again, and so on. Right? So what will happen? Okay, the light ray is continuously refracted internally. So this makes the diamond to glitter. Okay, so this is first use. Due to total internal reflection, the diamond glitters. Its next use is using the isosceles right angle prism, we can deviate the light rays by 90 degree or 180 degree. Okay, so see, let's see the first one. Okay, this is the first one. When a ray of light is entering normally, what will happen? It will pass in the same direction. Now this is the normal. Okay. Now this angle is 90. This is 45 because we have taken isosceles prism. So this will be also 45. So this is also 45. Clear? This angle will be also 45. Now for prism, if we take prism of crown glass, then the refractive index is approximately 41 degree. And for flint glass, it's nearly 37 degree. Right? Crown glass, flint glass, there are two types of material of the glasses. Crown glass, they are having lesser refractive index relatively compared to the flint glass. Flint glass are having relatively higher refractive index. So what happened in both the cases, the critical angle is less than 45 and this angle will be 45. So what will happen? It will be reflected internally. And as it reflects internally, it obeys the law of reflection. So this angle will be also 45. You will see this ray. Okay, if there is any other ray passing in this way, it will be in reflected in this way. Clear? So see, we had deviated by 90 degree. It was going in this way and deviated by 90 degree. Clear? We can also deviate it by 180 degree. Okay? If we take the prism in this way, let's take the first ray. As it is entering normally in the same direction, as we said, this is normal angle 45. Again, angle this is the normal angle 45. This is incident ray. This is reflected ray. Okay. If there is another ray, it will be in this way. Clear? So see, the rays were moving in this way and were deviated in this way. So this is 180 degree deviation. Clear? Let's take one more figure. Okay, if I take a glass having shape in this way, see, then what will happen? When the ray of light is entering here, what will happen? This is the normal, so bend towards normal. Okay, angle greater than critical angle, so it will move in this way. Okay, when the ray and then this is the normal. Oh, just a minute. Let's take two rays together. Let's take this position as A and this as B. So see, this is the normal. Means 90 degree. Okay. So what will happen? It will bend towards normal. So it will be in this way. Okay. Now the reflected ray in this way. Now see, this was the ray B. So this is B and A. So the image object, if here will be object, then the image will be inverted. Okay, clear? So this is one more example. So this is the second use of total internal reflection. The next is mirage formation. Okay, now in the time such as summer, okay, what happened? You might have observed that if a tree is there, and you might observe that the image of trees appear on the ground, or if you are in road, then you can see the image of the tree on the road. Now that is not a mirror, but still you can appear its image, right? You can see its image. So now see what is the logic for that. What happened in summer? The surface is ground is hot, right? So what happened? The air that is closer to the ground, or air that is in contact with the ground, okay, becomes hot, and due to that it will be optically rarer. Okay, if there is a tree, okay, see this region will be optically rarer, and the top region as you move away it will be cold air, so that will be optically denser. Okay, so now when the ray of light is entering from here, okay, when ray of light is coming from here, what will happen here? When the ray of light enters here, if this is the surface normal, this is denser, optically denser, optically rarer. So when a ray of light enters from optically denser to optically rarer medium, it will move away from normal. Right? Again the same thing, away from normal. Again the same thing, away from normal. So this ray will be in this way. So what happens if there is an observer at this place. Let's say anyone is observing it from this place. So when this ray, it will bend. Okay. Now when it comes here, it becomes parallel. After the ray is entering in this region above, then it enters from rarer to denser. So in that case, this will be normal, it bends towards. So it bends in this way. Right? Okay. So what will happen? Like this way. Now our eyes perceives the light traveling in a straight direction. So what will happen? The image is found to be in this way. Clear this point D and it will be appeared at that point. Right? This is mirror formation. Clear because the air that is in contact with the ground is hot, so that is optically rarer, and the air above is optically denser, right? You have already studied this in standard and okay, you have also studied one more topic that is looming effect, right? In that case, you can observe that boat that is on the surface of the water, you can see that it's lifted up because the air in contact with water at that time is colder. So due to that reason, it is observed in that way. Okay, so at present this is mirage formation. Its next use is in optical fiber. Now see student, optical fiber, its main use is in communication. I would say telecommunication. For transmitting and receiving the signal, optical fiber is mostly used in telecommunication. Also, it is used for broadcasting cables, right? These cables are very lighter, okay, and they are also flexible. Okay, so they are used in broadcasting. These cables, optical fibers are used there. It can carry the data, okay, effectively, more amount of data effectively and without the leakage of information. See here, this you can see the structure of optical fiber. Now see, what is this optical fiber made up of? Optical fiber is made up of long, thin fibers made up of glass or fused cords. Fused cords, it is highly transparent. Okay, so it is made up of glass or fused cords of 10 to 100 micrometer diameter. Okay, so these fused cords are used to, and from that long thin fibers. See these long thin fibers having a diameter of 10 to 100 micrometer, right? So it's very less. Okay, the outer surface, this is called cladding. Now this surface is having lower refractive index, lesser refractive index compared to this core region. Okay, so this is called cladding. Okay, so let's take this as N2, this as N1, and N1 is less than N2. So it's in absence of cladding due to dust particle, okay, the surface can damage and even there might be the leakage of the light rays. Okay, so this is the structure. Now see what happened when a ray of light is incident. Okay, this is the normal. It will be reflected towards normal. Now here, okay, the angle it will make will be higher than critical angle, right? So it will reflect back again in this way, and due to this, the light ray is totally internally reflected, and this information in the form of light that can be transmitted to a very long distance. Okay, now let's take this in detail. Now, let's as shown in figure. Here it is. Let's take an example of optical fiber. Okay, this will be the surface. So if I take a ray of light, okay, then this will be the normal. So what will happen? As it is entering from air to optical fiber, it will bend towards normal. So it will bend towards normal. Okay. Now this is the normal at this place. Okay, that is the normal. Say if this is the angle of incident I, theta I, then this will be the angle of refraction theta I. Clear? Now this angle, as you can see, it is 90 degree. So this angle will be 90 degree minus theta. Okay. Now we want that this ray must reflect internally. We, we don't want any leakage, right? We don't want this ray to transmit outside. Okay, we want it to reflect internally. Now, when this is possible, okay, total internal reflection is possible when the angle of incident is greater than critical angle. So this angle 90 degree minus theta must be greater than the critical angle, then only it will reflect internally. So we want 90 degree minus theta higher. Okay, this must be of higher value. Okay, now let's say theta r. So now, if we want this as a higher value, we must take this theta r very less. So for that, theta r must have very less value. Okay, so theta, angle of refraction, if we want it to be smaller, the angle of incident must also be smaller. That means theta I must also be very small. So, for that, the angle of incident must be very small, right? It will be best if we are entering it normally. Okay, means normal to this surface. Clear? So, this is about optical fiber. Remember, I am repeating once again, this is the incident ray, this is angle of incident, this will be angle of refraction. Now, this is the angle of incident at this point. Okay. So now this is normal. So this angle 90, this angle of incident will be 90 minus theta I. So if we want this ray to be totally internally reflected, this angle must be greater than critical angle. So higher the angle or higher this angle, higher the chances of total internal reflection. So this angle must have very higher value, and for this to have higher value, we must have theta r very less. Right? See, if theta r is 40, then this angle will be 90 minus 40, 50. If theta r is 30, this will be 90 minus 30, it will be 60. If theta r is 20, this will be 90 minus 20, 70. So lesser the value of angle of refraction, theta r, higher the value of this. Okay, and for that we require very small value of angle of incident. Clear? So just go to this. Okay, students, so that's it for today. Thank you.